Alright, let's do this. Let's predict the test set results. So, as I said in the previous tutorial, we're going to display two vectors. First one being the vector of the real profits in the test set, and the second one being the vector of the predicted profits in the same test set. And we're going to compare next to each other to see if our predictions are close to the real results. Alright, let's do this. Let's start by creating a new code cell. So the first thing I asked you to do was to indeed get that vector of predictions. So first, since we want to get a vector, I'm going to introduce a new variable, which I'm going to call, as usual, yPred. So that's going to be the vector of the predicted profits in the test set. And now, how do we get our predictions? Well, you know the solution. It's actually exactly the same as with simple linear regression. We first need to take our regressor object, our multiple linear regression model, from which we're going to call that predict method. And of course, in this method, we have to input the features of the test set, exactly these ones, not including the profit, of course. These are all the features with first the encoded variables for the state, then the R&D spend, then the administration spend, and the marketing spend. All right, so these are all the features which we need to input in our predict method here in order to predict the profits. So let's do this. X test, and there you go. Now we get our vector of predicted profits. Perfect. And now the next step, the thing that I'm going to do is I'm going to call numpy, which has a shortcut np, from which I'm going to call one of its functions, which is set underscore print options. And now in the parenthesis, I'm just going to enter precision equals 2. All right, and this will display any numerical value with only 2 decimals after comma. All right, so this will be much more beautiful to visualize and mostly much easier to visualize. Okay, good. And now final step. This is a step where we're going to display the two vectors of the real profits and of the predicted profits together next to each other. And to do this, well, we're going to use, a classic trick with numpy, concatenate. Concatenate is a function of numpy that allows to concatenate either vertically or horizontally two vectors or even arrays. And so now we're going to use the concatenate function to concatenate vertically our two vectors of the real profits and the predicted profits. All right, so let's do this. Just follow me. I will explain everything as I'm coding. So first, we're simply going to start with a print, because we want to print that concatenation of the two vectors. Then, here we go. We're going to call that concatenate function by numpy, from which, there we go, we call the concatenate function. Perfect, parenthesis. And now be careful, because this is always a bit confusing. The concatenate function by numpy actually expects as a first argument, check this out here, the tuple of arrays you want to concatenate, or vectors. So actually all the description is here, A1, A2 is a sequence of arrays you want to concatenate, and that must have the same shape. Well, that's perfect for us because of course our vector of predicted profits and the vector of real profits have exactly the same shape, meaning they are a one-dimensional vector containing the same number of profits. Okay, so that's good. But these vectors that we want to concatenate have to be in some parentheses, and these are actually the first argument. This tuple of arrays or vectors is the first argument input in parentheses. So here I'm going to add new parentheses. All right, this is the first argument. And what is going to be inside these parentheses? Well, of course, are two vectors, the vector of predicted profits and the vector of real profits. All right, so let's first add the vector of predicted profits. This is, of course, yPred. And now, because we want to display them vertically and not horizontally, remember that, actually I can show this to you in data preprocessing tools. We actually printed y at some point. There we go. Remember when we print the dependent variable vector, since it is vector, it is displayed horizontally. I actually prefer to display, our two vectors of predictions and real profits vertically. So now I'm going to add another trick to put that vertically, to convert that from being horizontal to vertical. And the trick to do that is just to add dot reshape. Reshape is an attribute function that allows to, reshape your vectors or arrays. And in order to reshape a vector from being horizontal to vertical, well, we just need to add as input of this function, first, the number of elements in yPred, and that's actually so far the number of columns because it is horizontal. And to get that number, we can simply use the len function, which returns the length of a vector, and therefore here I'm going to input ypred. Okay, so this is the first element of the reshape function, and the second one is just 1. All right. So what does it mean? That means that you want to reshape your ypred vector into an array having len ypred rows, meaning you know that the number of rows will be equal to the number of startups, and then just 1 column. All right, that's what it means. So it's good that you know this reshape trick. Now you know how to reshape your vectors, and you will see that it is actually going to be much nicer.